Okay, today we're in section 13.1, starting chapter 13. We're going to be in chapter 13 for a while, between facts next week, spring break, SATs at the end of the month. There's just a lot going on that's going to kind of disrupt the normal flow of testing every 2 weeks. That's pretty much not going to happen for the next several weeks, just because of all the breaks and whatnot. But we're going to continue kind of just working through these sections whenever we meet as a class, and we'll get through the first couple before we release next week, and then we'll go from there. All right, so starting in 13.1, this is going to be a two-part lesson. We are learning about linear equations today. Well, I mean, if I'm calling it a linear equation, there's something also known as a nonlinear equation too, but you don't learn that in pre-algebra. You're only learning about linear equations. When you get to Algebra 1 next year, you start seeing different kinds of equations, all right, not just linear. So a linear equation is kind of what it sounds like. It forms a straight line on a graph. You need to know that in an input-output table that X is the input and Y is the output. If I put a value into an equation, the answer I get is my output. That's the value that comes out of it. And I must have an input-output table. I have to have a table of values to graph in the first place. If I don't have a table, I have no ordered pairs to graph. I have nothing to go off of. All right, so that's probably one of the hardest parts of this is you have to understand that's not going to be given to you. It's subjective. What does the word subjective mean? Anybody know? There's not just one clear answer, okay? I know, we like objective, right? Where I just say, this is how it is, and you just do it every time, okay? But with linear equations, the solutions are not cut and dry like that, okay? Because there are actually many solutions to even just one linear equation. All right, I know I kind of just went on this whole long tangent. You're probably like, what in the world is she talking about? Okay, I'm gonna explain it. All right, just go ahead and get everybody have these written down. You ready? You done? Okay, give you another minute. All right, so example 1. Before we graph, all right, we have to understand okay, so to plot a point on a graph, I need an ordered pair. An ordered pair tells me where the point goes. Everybody remember what an ordered pair is? Maybe that's where we need to start. Everybody remember something like this? An ordered pair? Okay, so an ordered pair tells me where to plot the point on the graph. So I need to come up with an ordered pair that would be a solution to that equation. Well, how does that work? How do I come up with, and by solution I mean it makes both sides of the equal sign the same value. Here's how I do it. I set up a table of values. All right, and I have a couple rules that will help me determine what values I need to use and plug in, okay? I need 3 columns here, okay? And then my last one can be a little wider. All right, so then I've got 1, 2, and 3. Oh my goodness, that's awful. Let me try again. Try to make these lines a little straighter. Oh, a little better. Okay, so my first column are my X values, then my Y values, and then I have my ordered pairs that come from it. That's what I'm really trying to get at is, okay, what ordered pairs are solutions to the equation that I can turn around and graph on a graph? So the catch with your X values, guys, is you literally could choose whatever number you want to plug into this equation. You can choose any number you want. Any number. Pick a number, 120. You could pick 120. Why would you not, thinking in terms of, I have to graph this, why would you not want to put 120 into your equation? Because your graph is going to be ginormous. Okay? I don't want to take 18 pieces of paper together or have to have huge intervals, right? That's pointless, okay? So we want to keep our numbers small. So here's my rule. If I have a whole number connected to x, and we're going to talk about the significance of this number in 13.2 in the next section. But for right now, I just need you to look at the number connected to x. Is it a whole number? Yes. So anytime there is a whole number connected to x, I am going to use the same set of values. -2, 0, and 2. Could I do -1, 0, and 1? Sure. Okay. But just for consistency across, could I do -3, 0, 3? Yes. But for consistency across everybody and to make it a million times easier to grade your papers, if we're all using the same input-output values, it's just way easier to grade and we're still accomplishing the goal that we want to accomplish. Okay? So when there's a whole number connected to x, say it with me, what three numbers do I use? -2, 0, 2. Okay? So what do I do with these x values? Remember I called them input values. Well, where would I input the value, do you think? In for x into the equation. So plug in -2 into your equation. What is 2 times -2? What's -4 plus 1?
-3.
Yes, -3. So, does everybody agree when I plug -2 into the equation that what comes out of it, the answer that comes out of it is -3? Everybody agree with that? Okay, so I would say that -2, -3 is a solution to this linear equation. What does that mean? I'll show you, so hopefully this kind of comes full circle. If I plug in -2 for x and -3 for y, is it true -3 equals 2 times -2 plus 1? Yes. -3 would equal -3. You do not have to show that. Okay? All I'm doing is showing you the reason this ordered pair is a solution is I can plug them back in and it equals out in the equation. Do you guys see that? Okay. So that's what's happening. So I'm just going to erase this because, again, you do not have to show that. Okay, so now let's do it with 0. Plug in 0. What's 2 times 0?
0.
Plus 1?
1.
So my second ordered pair is 0, 1. If I plug in 0 into the equation for x and 1 for y, both sides are going to equal. All right, do the last one. Come up with your output value and your ordered pair. Some of you are not writing because you already did it. Good. That's fine. What was your output value?
5.
2 times 2 plus 1. All right, which is 5. 2, 5. All right, so we're going to pause there. But technically, I'm ready to graph this linear equation. I have 3 ordered pairs that I've substituted in now, and I know that they are solutions to the linear equation. I'm ready to graph. But now, before we do that, I want to do one more. Okay? Oops. I want to do one more. All right, so go ahead and set up your table. And guys, the instructions on your homework, they're not going to say anything about a table. They're not going to say anything about your input values. All it's going to say is graph the linear equation. But you know you have to do this to get to the graph. Okay? It's not going to say anything about the table. All right, so 1. Close enough. All right, so I have x. And I have y. And then I have my ordered pairs. Sometimes I'll just abbreviate it OP if I don't have enough room. OP for ordered pair. All right, so now here's my, are y'all still setting it up? Okay, I'll give you another couple seconds. All right, so here's the problem here, all right? If I use the standard set of numbers, -2, 0, 2, I do not have a whole number connected to x. So let's just say I'm going to go with it, all right? And I'm going to plug in -2 for my first x value in here for x. Negative 1/3 times negative 2 over 1. What's that going to equal? No, 2 times 1 is 2/3. So if I use my standard set of numbers, my output is going to be 2/3. Is that going to be fun to graph? No. Technically, that's the solution. And technically, I could graph that, but why would I want to when I literally could choose any value I want for x? So why not change it up? Why not choose a value for x that could, yes, that could evenly cancel out the fraction? I will choose a multiple of the denominator. Choose a multiple of the so if the denominator is 3, I'm going to choose -3, 0, and 3. If the denominator is 5, I'm going to choose -5, 0, and 5. What if the denominator is 4?
-4, 0, and 4.
Okay, because that way I'm not going to have a fraction for y. I don't have to deal with that. I don't have to worry about it. Okay, so calculators are allowed in this chapter. So, you know, that's okay if you use it to maybe check, but we really shouldn't need them to do -1/3 times -3 over 1. These are reciprocals, right? So they all cancel out, right? Negative times a negative is a positive. So what's 1 plus 2? 3. Okay? That work up there is not something you have to show. Okay? You just need to fill in your table. All right? So my matching ordered pair is -3, 3. I want you to fill in the rest of the table now. So 0 plus 2 is just 2. And then 0, 2. Okay? Now, guys, when you plug in a +3, this into your fraction, -1/3 times +3 would be -1. -1. Because there's only one negative.
Oh, yeah.
Do I need to show you that? -1/3 times 3 over 1. Everything still cancels down, but since I only have one negative, my answer is -1. Again, you don't necessarily have to show that, but that's why your answer is -1. So if it's -1, what's -1 plus 2? 1. 3, 1. All right, guys, now we're ready to graph. So you have 2 problems like this on your homework tonight where you're going to do your table, okay? One is a whole number connected to x, the other one's a fraction. 2 problems. You think we can do it? All right, so now we're gonna graph both of these on the same graph. We're gonna do 2 graphs today. All right, 2 graphs today on graph paper. Go ahead and set up your graph paper. We're gonna set up 2 graphs on your graph paper. Okay, so now I'm going to graph these 2 equations. All right, now my screen doesn't have the input-output table that you just created on your paper, but you have it. All right, so you need to look at your paper, okay? And, sorry, we are doing the other one too. Y equals -1/2 or 1/3 x plus 2. We're doing that one too. All right, so on the first one, what was that first ordered pair, the y equals 2x plus 1? What was the first point, the first ordered pair? What was it, guys? -2, -3. Then what? 0, 1. Then what? 2, 1. And remember what we're graphing here, guys. We're graphing a linear equation. So it should form a straight line. Does it form a straight line? Yeah. All right, so that's a really good indicator that I actually did it right. Okay, and now you're going to label the linear equation that it matches. Y equals 2x plus 1. All right, there's a couple things here that are really important for us to understand. What is happening here on this graph? Okay, we graphed how many solutions to the equation? How many did we graph?
3.
How many points? 3. But what this line is showing me, what do those arrows on the ends mean? Those are really important. What do they mean, the arrows? They mean that the line keeps going to infinity. So what is the significance of that? The significance is that this line actually represents millions, yes, I said millions, of solutions to this linear equation. Let me show you. So we graphed 3 solutions, right? Let's find another point on this line where the x and the y clearly cross. Okay? What about this point right here? What about this point right here that I'm doing in green? Is it true that the x and the y clearly cross the line right here? Yeah. Right here? Okay. So let's test that ordered pair. That ordered pair, we're kind of doing it backwards now. We're saying, well, based on the way that this line is trending on the graph, that ordered pair is supposed to be a solution to the equation. What is the ordered pair? 1, 3. So let's test it. When I plug in 1 for my x value, what's 2 times 1?
2.
What's 2 plus 1?
3.
3. And that was my output. So, okay, if you can put that together, that's really important. What does this line, all the points in between, the 3 points I graphed, they are actually all solutions to the linear equation. You get that? So is there just 3 solutions? No, there's an infinite number of solutions to the equation. I just happen to do 3 of them. All right? Okay, so I'm going to kind of backtrack because I'm going to get my other graph on here too. Okay, so now for negative 1/3 x plus 2, what was my first ordered pair?
3.
Okay, negative 3 up 3, then what?
0, 2.
0, 2, then what?
3, 1.
3, 1. All right, and draw my arrow, and then I write my equation. Negative y equals negative 1/3 x plus 2. All right, the last thing I want to point out here, and this is kind of jumping ahead a little bit to 13.2, but I just want to point it out to you. If I'm reading these lines, and this is really important, how do I read the lines on a page? From left to right or right to left? Left to right. We read a graph the same way. So from left to right, these lines are trending. So for the purple one, it's trending which way? It's going up. That means that it has a positive slope. Okay, again, we're going to talk more slope in a minute. Or not in a minute, in 13.2. But I want you to see that. And look at the green one now. Which way is it trending from left to right? Left to right, it's going down. So I would say it has a negative slope. The slope of the line is actually really, really important. So we have an entire section in 13.2 just about the slope of a line. Right now, I'm just trying to get the linear equation graphed. Then in 13.2, I'm going to actually look at the slope of the line. So for right now, can everybody tell the purple one is positive and the green one is negative?
Yes.
Okay. All right. So that's basically all I wanted to point out there. The rest of it we'll get to in 13.2. Okay. One more example, and we're going to stop here for today after these two. I want you to, do you have your second graph set up?
Yes. No.
Okay, so anytime, guys, we just have, and you have one of these on your homework, y equals negative 3, or just x equals 2, meaning there's no operation, it's just saying this is what y equals, or this is what x equals. This is going to be a horizontal or a vertical line. Does everybody know what horizontal is? Left to right. Okay, a straight line, and vertical is? Up and down. All right, so if it says y equals negative 3, I'm going to follow the y-axis down to a negative 3, and I'm going to plot my point. That is literally all I'm doing. However, you have to know, after I plot that point, there's only one point. Is my line going horizontally through it or vertical? Here's how you know. This is probably the easiest way I can explain this to you. The y-axis goes in which direction? Up and down. So if you graph a y value, you're going to go in the opposite direction of the axis. Okay? So y-axis is up and down. So you're going to go horizontal. Does that make sense, guys? And then arrows on the end. And that's it. That's a horizontal line. Gabe, how are we doing? Doing okay? Isaiah, how are we doing? Okay, not a lot of questions, so I feel like it's going well, but if at any point you guys have a question, let me know. All right, so what about x equals 2? Are y'all doing this on your graphs? What about x equals 2? Where do you think the point's going to go? Zach?
On 2, on the up at the top.
Yeah.
Oh, no, on the right. Yeah.
Yeah, on the right. Okay, very good. On an x value of 2. So again, remember what I said. Your line goes in the opposite direction of the axis that the point is on. So if it's on the x-axis and the x is horizontal, guess which way your line's going? Vertical. Okay, your line's going vertical. Just go ahead and draw it straight through. And again, yours can be on the same graph. That's fine. Okay. And the last thing, which I did forget at first, make sure you label your line. Y equals -3. Label the line on the graph. X equals 2. All right, guys, we're going to stop there for part 1 of section 13.1.